All right, this is using the quadratic formula to solve our quadratic equations. So here if we have our quadratic function in standard form, if we want to find the value of x, we're looking for the x-intercepts, right? We're looking for the zeros when f of x equals 0. So we're really substituting in 0 for our y, or our f of x, and we're solving for our x values. So a is the number in front of the x squared, the coefficient in front of x squared, b is the coefficient in front of x, and then c is our constant. So in this one, a is going to be equal to 1, right? Because there's really a 1 written in front of here. B is going to be equal to 6, and c is equal to 9. Now we could solve this by factoring, but they're wanting us to use the quadratic formula. Our quadratic formula is going to be x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So what we're going to do is we're going to substitute these numbers into the quadratic formula, and we're going to solve. So b is 6, so it's going to be opposite of 6 plus or minus. Whoops, that was not a good square root. Square root, b squared, that's going to be 6 squared minus 4 times 1 times 9 all over 2 times 1. Okay. So I'm going to simplify. This is negative 6 plus or minus. 6 squared is going to give me 36. Negative 4 times 1 times 9 is going to be minus 36. And then 2 times 1 is 2. So I'm going to get x equals negative 6 plus or minus. That's going to become the square root of 0. Right? So plus or minus 0, right? The square root of 0 is 0. So we're going to end up with x equals, well, we could do this, negative 6 plus or minus 0 over 2. Right? Plus or minus 0 is just nothing. So we're going to end up with negative 6 over 2, which is just going to be equal to negative 3. Okay, so we're going to put in our answer, x equals negative 3. Okay, and we're good. All right, let's try a little bit more difficult one. Okay, let's not try this one. Let's pick one where we gotta have some bigger numbers here. Okay, let's do this one here. All right, so when I plug in here, I gotta move, first of all, I gotta move everything to one side because we need to set it equal to 0. It needs to be like this. Okay, so I'm gonna subtract 70x on both sides. And I'm gonna get 49x squared minus 70x. And then plus 26 equals 0, right? I need to subtract 70x from both sides. And I need to add 26 to both sides. So these are going to cancel and give me 0 on the right. And then I get 49x squared minus 70x plus 26. Okay, I'm trying to think, is there a number that's evenly divisible into all of them? And I don't think that there is, right? 3 doesn't work, 2 doesn't work. And if 2 and 3 don't work, 7 doesn't work. So I think we're just stuck with big numbers, and that's okay. We can use big numbers here. So A is going to be 49. B is going to be negative 70. And C is going to be 26. And then I'm going to substitute those into my quadratic formula. So x equals negative times negative 70, or yeah, opposite of negative 70, right? Plus or minus negative 70 squared minus 4 times 49 times 26 all over 2a, that's 2 times 49. Okay, so we're just going to get some much bigger numbers here. So opposite of negative 70 is 70, plus or minus. 70 squared is going to be 4,900, right? Minus, so we got to open up a calculator. Let's just double check. 49 times 49. I'm sorry, 70 times 70. I was doing, yeah, 70 times 70, 4,900, right? And then we're going to do -4 times 49 times 26. That's going to be a negative 5,096. $5,096. Okay. All over, that's going to be 98. 2 times A. All right. 4,900 minus 5,009. So let's do X equals, right? Now we got 70 plus or minus. Okay. 4,900. And we can put that in the calculator if we need to. 4,900 minus 5,096 is going to give me negative 196. Over 98. Okay. Square root of 196, we're going to split that up into square root of -1 times square root of 196. The reason we're doing this is because we can't get a real number when we take the square root of -196. Okay. And we're going to turn it into the -1, which is I. All right, now we need perfect squares. I think that's going to be 49 times 4, or just square root of 196 is going to be 14, right? Okay. If you needed to check that, square root of 196 is going to be 14. Okay, so let me back up. Okay, so this is going to be I times 14. So square root of -1 is I. Square root of 196 is 14. That's going to be 14i. So let's put that in. We have X equals 70 plus or minus. Square root of 196 equals 14i, we just said. So instead of square root of 196, I'm going to put in plus or minus 14i over 98. All right. I have to divide both of my pieces by 98 now. Right? I have to, right? When I'm dividing, I have to divide both by the denominator. Plus or minus 14i over 98. Okay, 7 is going to be divisible into all of these. So so is 14. 14 is going to be divisible into all of these, right? So 70 over 98, right? 70 divided by 14 is 5. And 98 divided by 14 is going to be 7. So this is going to become 5 over 7. Right? This reduces to, and you can just put that in your calculator if you have the Inspire. Okay, and then this is going to become plus or minus 2 over 7 times I. Okay. I'm sorry, 1 over 7, right? 14. So that's just going to be 1 over 7. 1 over 7 I. All right, so my answers here are going to be X equals 5 over 7 plus 1 over 7i. And X equals 5 over 7 minus 1 over 7i. Okay, and we go back in and plug that in. Okay, so 5 divided by 7 plus 1 divided by 7 times I, comma, 5 divided by 7 minus 1 divided by 7i. Okay, and there you go. All right, let's do another one. So let's look at this one. Well, that's an easier one. Let's do another hard one. Okay, let's look at this one. This one should be good. All right, so A is going to equal 2. B is going to equal -5. And C is going to equal -12. Okay. So our quadratic formula again is opposite of B plus or minus square root B squared minus 4AC all over 2A. All right, so let's substitute in our numbers. X equals opposite of B, that's going to be negative times -5 plus or minus -5 squared minus 4 times 2 times -12. All over 2 times a, so 2 times 2. So let's see what we got here. Opposite of -5 is going to be +5, plus or minus square root. -5 squared is 25, plus -4 times 2 is 8. 8 times 12 is 96. So plus 96, right? 24 times 4, 48, 96, right? And it's a negative and a negative, so we get plus all over 4. And we get x equals 5 plus or minus. Combine those together, that's 101, 121. Okay, all over 4. So square root of 121 is a perfect square, so the square root of 121 is going to be 11. So we get x equals 5 plus or minus 11 over 4. So we're going to get x equals 5 plus 11 over 4. And x equals 5 minus 11 over 4. Okay. So didn't realize, delete all this. Okay. We're going to get here 16 over 4, which gives us 4. And then over here, we're going to get -6 over 4, which is going to reduce to -3 over 2. Okay, so our two answers are going to be 4, comma, -3 divided by 2. Excellent. Perfect. Okay. Let's try one more, I guess, right? Yeah, let's try one more. Okay, we'll try this one. Those are our perfect squares up there. We can leave those. All right. A in this one is going to be, we got to move everything to one side. So I need to subtract 7x from both sides. So I'm going to get x squared minus 7x plus 22 equals 0, right? Those are going to cancel. So A is going to be 1. B is going to be -7. And C is going to be 22. Okay. So x equals minus -7, opposite of -7, which is going to be +7. Square root -7 squared minus 4 times 1 times 22. Okay, this is a good one because it's going to end up being a complex number. 2 times 1. Oh, good. So that's going to be 7, right? Opposite of -7 is going to be 7, plus or minus. This is going to be 49 minus 88. 4 times 1 times 22 is going to be 88 minus. Okay, all over 2. So we're going to get 7 plus or minus, let's see, 59, 69, 79, 89. That's going to be 39. Okay. Over 2. Okay, sorry, this should be -39, right? 49 minus 88 is -39. So if we have square root of -39, we're going to split that up into square root of -1 and square root of 39. Okay. Square root of 39, we could split 39. Factors of 39 are going to be 3 times 13, but those aren't perfect squares. So there's no perfect squares. 4 doesn't go in, 9, 16, 25, 36, right? There's no perfect squares that go evenly into 39, so we can't reduce it anymore. It's already simplified, right? So it's just square root of -1 times square root of 39. The square root of -1 is I, and then we have square root of 39 left. Okay, so we're going to put in x equals 7 plus or minus I times the square root of 39 over 2, right? And we can split both of those, right? The 2, we got to divide both of those by 2. So 7 over 2 and I over 2, right? We're going to divide both terms by 2. So then my two answers here are going to be 7 over 2 plus, I'm going to put square root of 39 over 2. And I could put the I on the numerator, or I could put it on the outside. I'm going to put it on the outside so it looks like our A plus BI, our complex number, written as A plus BI. So this would be B, this would be A, and then you got your I. So then this is 7 over 2 minus square root of 39 over 2 times I. And those should be our two answers. So let's try them out. 7 divided by 2 minus square root 39 divided by 2 times I. Okay, comma. 7 divided by 2 plus, whoops, plus square root of 39 divided by 2 times I. Okay. Excellent. Okay, and that's going to be those 4 good examples of using the quadratic formula.